All right, thanks very much. Hi everyone. Hope you have a great morning so far. A lovely day to be here at DDD Perth. I'll be talking today. My talk is Hobbyist to Open Source Founder. So I've got this quote here from Arthur C. Clarke, who says that any sufficiently advanced technology is indistinguishable from magic. And I think this is so relevant nowadays when you don't even have to be someone who's technical, who knows JavaScript or anything, to be able to kind of put prompts into an LLM and be able to generate entire applications that are able to do things. It's pretty magical that this is technology is around nowadays, and a lot of it is also accessible for free. I think that's also pretty amazing as well. So my talk today is going to be a little bit about my own journey and how I got started in software development and to the point where now I'm trying to launch my own open source software. But it's also going to be talking about what open source software is and how you might have your own interactions with open source software as well. My hope today is for everyone to come away with some sort of understanding of how you might want to interact with open source in the future as well. So if you're interested in, I'll be going through a bit of research and have some references and all that, so those will be available on my website here, or you can follow the QR code. I'll have this up at the end as well. But before we go any further as well, I'd like to thank, again, our sponsors for making DDD possible. Without their support, we wouldn't have the venue and we wouldn't be here today. So I will be talking a little bit about software licenses. So just a bit of a disclaimer, this is not legal advice. I've done a bit of research into the software licenses and stuff like that, but please don't, please take my advice with a grain of salt and advise that you seek professional advice if you're going to be making big decisions based on your licenses. A little bit about who I am. So I'm a consultant at Visagia Australia at the moment, involved with their VDev and their VLabs units. So you might see us with our shirts around today. Feel free to come and say hi. So I'm doing software development and analytics as part of that. But before that, so I studied computational physics at UWA down in Wembley, Crawley. I can't remember anymore. It's been too long. So I'm also an avid consumer of YouTube video essays and science edutainment like 3 Blue, 1 Brown and Veritasium and all that kind of stuff. And I also consider myself, a bit of a, quite a values-driven person. And so, my kind of journey here to trying to launch my own open source software started, a long time ago. My first actual kind of interaction with trying to build software was Scratch. We did this in high school as part of like a little thing, trying to learn a bit of development, right? But for me, like software development was, never something that was kind of. It was always something that was a bit abstract, right? So I was good at the science, like the STEM and the mathematics and all that, but I wasn't a computer science kid, right? Computer science was the thing that the ducks at my school did, not someone like me. But then, I wanted to pursue physics, and and as part of my degree, I had to kind of choose a specialization, and I chose computational physics. And as part of doing computational physics, you're able to solve equations to see how things kind of propagate over time, for example. So what you see on the left there is an example of a particle moving in some sort of symmetric potential there. Believe it or not, so they were teaching us Fortran at UWA when we were doing this. So this is written in Fortran, and apparently people still use Fortran today. I'm surprised, but that was on the left there. And then I used a program called GNU-plot to be able to put these, do these plots, and then animate them together. And this is the first time, like this is, even using something like, Fortran and GNU-plot, this was quite magical for me because, prior to this, like solving these equations just meant, we had like, rows of data, right? The best I could do plotting them before this was in Microsoft Excel, which, we all love to an extent. But you can only go so far. Now, the great thing about my experience at UWA is that we also had access to academic license for this thing called Mathematica. And so with Mathematica, we're able to make these really beautiful plots. And so I was spending a lot of time making these kind of beautiful mesh plots and things like that as well. And it's a great kind of like user-friendly experience using Mathematica. So towards the end of my degree, that was when I started my internship at Visagio, and I started getting into a lot more more serious Python development, and also using Plotly and things like that. And I think Plotly was something which was really great because Plotly is a free and open source library, and I was able to learn to use it quite well, and I eventually used it as a lot in part of my thesis. So on the left there, you can see some of the plots that I had there. And the great thing about using something which is free and open source like Plotly is that all the skills I'd gained in terms of how to build these plots and stuff like that was all stuff that was easily transferable after I left UWA and didn't have access to using stuff like Mathematica anymore. And then finally, so during my first years at VDev in Visagio, I learned a lot in terms of software development from my peers and mentors, and eventually had experience working in front-end projects as well. And at this point, I'd felt that my background was not really in software development, so I felt like a bit of a fake developer up until that point. Software development and the computer science and all that was for the people who got 99.95 ATARs and such, right? But through through spending time using stuff like 3JS, like you saw in the animation there, and through mentoring and coaching from my peers as well, I was able to gain the ability and the confidence that I would be able to do things with code. And it's a really cool thing still, to be able to have the ability to make something which is tangible to an extent. Sure, we can't touch it in person, but it's pretty cool. It's pretty cool stuff. And eventually gained the confidence to be able to to call myself a developer. And so that was only possible because of all of the different types of open source software that had come before, and that I was able to leverage and build up on top of. So these are just a few of the examples of open source software that I've used as part of my journey to get to this point. Can I get a show of hands? How many people have used any of these that you've seen before as well? Okay, literally everyone in the room. Okay, so to speak to how much impact that open source software has. But I want to talk a little bit about what actually is open source software, and how did we get to the stage where we've got so much of this which is available for free for everyone to use. So we're talking a little bit about the history. So in the 1950s, that's when you've got your languages like assembly, Fortran, Lisp, COBOL, all these really old school languages. This is the time when those languages were being born. So this is very early days, and the people who were playing around with computers were researchers and hackers, and it was a very open and collaborative environment back in these days. The idea of proprietary software, this was only something that came about later on, towards the end of the 1960s, when companies realized, we could have a competitive advantage by having our code be in-house, and we could benefit from that. And so from there, that became one of the more dominant models of producing software. And then in 1983, a guy called Richard Stallman came around. He said, "Don't like that. I think we can do better than this." And he founded the GNU project. So I know that Kate said, no acronyms, but GNU is a little bit tricky. It's a recursive acronym. So GNU stands for, as far as I can remember, GNU is not Unix. So it's a tricky one. But he started the GNU project and what we call the Free Software Foundation as well. So when you hear the term free software being thrown around, what do we mean exactly by that? So in his words, so think of free in this case, not as in free, well, more as in free speech, not as in free beer. So when we talk about free software in Richard Stallman's terms, so it's talking about a set of freedoms that are afforded to us as users of that software, right? So as a user of free software, I have the freedom to run the software as I wish. I have the freedom to study and change it. I have the freedom to redistribute copies of it, and the freedom to distribute copies of modified versions of that software as well. That's what it means for a piece of software to be considered free software. The way that we're able to enforce that a piece of software is free software is through the license that it has. So a license is a type of legal instrument that governs how the software can be used and how it can be distributed. And so all software that you see on GitHub that is open source, right, has a license associated with it. Right? The license is what gives us the us as users the ability to use that in a legal sense. By default, something which does not have a license is unlicensed and it doesn't have any kind of permissions that it grants us. So we can't use work that is not licensed. So in particular with the free software movement, one of the things that Richard Stallman created was the GNU GPL. So the GPL here stands for General Public License. And it was a particular type of software license with some particular rules. And the gist of it, I kind of tried to boil down into here, but there's a lot of kind of disclaimers here. So if my program contains a dependency which is GNL GPL licensed, and then I distribute my program, then my program must also be licensed under the GNU GPL. So this is the kind of the main innovation that came about from the GPL, and this kind of viral nature of the license, where if I use something which is GPL and then I want to distribute my own software, it also has to be GPL or a compatible license. This is called copyleft, and so this is something that that Stallman had kind of coined in order to facilitate the free software movement. So the free software movement was kind of in opposition to proprietary software. So it was quite a political movement in a sense as well. And not everyone necessarily agreed with this way of thinking. And so later on in 1998, this is when the open source initiative came about. So this was founded by a group of people who broke off the Free Software Foundation. So when we talk about open source, similar to how free software doesn't literally mean free software, open source also doesn't literally mean open source. Makes the definitions fun. So open source software is, as defined by the Open Source Initiative, follows a number of conditions as well, right? So some of these conditions are the software must be free to redistribute, the source must be available, so open source is a precondition. We must be allowed to make derived works from it, and there's also no discrimination in terms of who can use the software and what that software can be used for. So these are all parts of the definition of open source software, as well as a number of other conditions as well. And similar to how we've got stuff like the GPL, which was a license that was created by the free software movement, we have a lot of licenses which are endorsed by the Open Source Initiative as well. So probably the most common example is the MIT license, or named after MIT. So this is literally the entire license here. You could just read it verbatim, but I'm not going to do that because that's boring. The gist of it is, okay, as a piece of software with the MIT license, you are allowed to do anything you want with it. The only thing you can't do is sue me as the person who created it. I hold no liability on what happens to you if you use this. That's what the MIT license says in a nutshell. So it gives you a lot of flexibility in terms of how you can use it. And the examples before of like 3JS and Plotly, so these are both examples of libraries which use the MIT license. So one way that you can kind of think about a lot of these type of licenses is on a spectrum from more restrictive ones to the more permissive ones. So on one end of the spectrum, you've got the GPL, which is a little bit more restrictive in that it has this kind of copyleft property. You've got some that kind of sit in the middle as well, like the Apache 2.0. And then you've got the more permissive licenses, like with the MIT. So kind of looking at to kind of make that a little bit more concrete, so here are some of the libraries I mentioned before, like 3JS, Plotly, GNU Plot. So all of these are examples of free and open source software, right? And so all three of these are considered both free software and open source software. And when we're talking about the intersection of these groups, which is a lot of software, we call that free and open source software. There's only like really few edge cases that you might consider to be open source but not free software. So most of it does overlap. And again, so open source software so it can also be copyleft, right? The copyleft property is not something that all open source licenses have, only a certain subset of them. And again, that's a different concept from being source available. So HighChart is actually an example of something which is a proprietary software, but is actually source available. You can go and go and look at the source code for HighCharts online, for example, but that doesn't mean that you can use it as you will. And then you've got proprietary software which is not source available as well, like with Mathematica. So we've talked a lot about what open source software is, but what actually drives people to create open source software and to contribute towards it. So there was a study that was done in 2002 looking into the motivations of why people contribute, right? And these were some of the things that they had listed. So of the respondents, like these are the percentages of respondents who kind of said this is a factor in terms of why I contribute. So to learn new skills, to share knowledge, to try a new form of collaboration, to improve existing products, to participate in the scene, or as part of the kind of ideology with free software. So this was also revisited a bit more recently in 2021. So on the left there, you can see here are the kind of reasons why people kind of contribute, back in the early 2000s, and then on the right you've got 2021. A few kind of key things that I found interesting with the number of people who are contributing to free and open source software for their own use has actually kind of reduced since the early 2000s. So the number of people doing it, for their own purposes, whereas the number of people doing it for a sense of altruism, for a sense of fun, or a sense of kinship, those have all gone up since the early 2000s. And so in this 2021 paper, so the main reasons that people did contribute individually to free and open source software was for a sense of fun, for a sense of altruism, or giving back to the community or doing good, or also a sense of kinship to that community as well. So free and open source software isn't something which has just been embraced by individuals around the world. It's also been something which is embraced by corporations as well. So in this report from the Harvard Business School, so they look at some of the reasons why small-scale enterprises, such as startups, contribute to open source. So they find a robustly positive relationship between open source software contributions and entrepreneurial growth, right? So the ways that these kind of startups are able to get benefit from this is by being able to shape the direction of open source code that they contribute to. They're able to signal their own quality as a startup to potential investors and acquirers, and they're also able to attract and engage users and other potential commercial customers as well. So very different motivations on the kind of commercial front, but all kind of very strategic as well. So in terms of large-scale enterprise, so Google is an example of this as well with Chrome and Android, and so there was actually a leaked memo, which I've got linked here if you want to have a look at the links. But one of the quotes out of that is, so from Google, so by owning the platform where innovation happens, Google cements itself as a thought leader and direction setter, earning the ability to shape the narrative on ideas that are larger than itself. So quite some kind of bold words here, but the kind of gist of it is that even Google saying by having a stake in the open source community, we're able to kind of influence direction and influence people's thoughts of it as well. So for large scale enterprise, this kind of contribution can mean strategic influence over that ecosystem. It can also mean leveraging the free and open source software community to help improve your products, right? If you've got 1,000 eyes looking at your code, like being able to spot bugs and things, you're going to be a lot more effective at solving and squashing those bugs than if you just have a small in-house team. And another reason is, in some senses and in some cases, also to collaborate with other companies and, in a sense, share R&D costs. So one thing which is kind of grown a little bit in recent years is the idea of an open source program office. It's a similar idea to a PMO or project management office, if you're familiar with that. In that, an OSPO is something that is an entity within an organization that manages how that organization interacts with open source software in terms of consuming it, but then also in terms of how it might contribute back or release its own open source software. And the idea of an OSPO doesn't mean you need to have lots of people kind of like working full time specifically dedicated to this. It can be a capability which is produced by a few people as well. And so in this report from the Linux Foundation, they found that organizations with an OSPO saw improvements in software quality, developer experience, development costs, generative AI risk management as well. So quite some strong benefits associated with having an OSPO. All right, so that was a lot of content to go through, but to kind of summarize that, right? What exactly is open source software and how did we get here, right? So open source software, free software, they're defined by those kind of definitions that we mentioned before. It's software that guarantees its users a certain set of freedoms, right? It's not exactly the same as source available and zero cost software. Those are components of it. And we can think of open source software on a spectrum from the ones which are more restrictive to the ones which are more permissive as well. Now, in terms of how, why people contribute, right? For a sense of fun, altruism, kinship for individuals. For enterprise, it's more strategic reasons, such as being able to influence the landscape, or and one way in which they're able to kind of have this is through OSPOs to manage their risk and improve their own technical outcomes as well. All right. So we've talked about open source software. Let's have a look at some, right? So I mentioned Three.js before, which is what I used to create that that n-body simulation visualization you saw before. So we can literally go onto their GitHub website, and we can see all the code here. And this is stuff that we're able to clone and download. If we look in the root directory, we're also able to see the license file here. So this is the file which defines how we were allowed to interact with this piece of software. Now, one of the cool things about open source repositories like this on GitHub as well is that they don't just have the source code there. They've got things like this issues tab, right? We can go here and we can see what are the different issues that are being raised by different people. How are people interacting with this, right? And so when I was using Three.js to kind of put together that visualization that you saw before, right? I was working through, building my example, and I thought I found a bit of an inconsistency or a bit of strange behavior in Three.js. So what I was able to do, because they've got their issues open like this, I was able to kind of create an issue there and say, hey, I think I found some kind of strange behavior. Is this actually intended? Like what's going on here? And it was only within a matter of days when one of the maintainers had kind of responded to say, hey, what you're seeing here is the intended behavior. But here are some ways in which you can do what it is you're trying to do in the first place. And so it was just, it was a very quick turnaround, and getting such a great detailed response from someone who kind of seemed to care that, I wanted to seem to care for, the outcome that I was trying to produce. This is, really, really positive experience for me. And this wasn't my only kind of time interacting with open source software, apart from just using it. So there was also there's a more kind of esoteric package called NexoSim. So this is a package which is used for high performance simulations when you've got multiple agents trying to interact in parallel. And so what I was trying to do was what I considered to be a pretty basic example, right? And for some reason it was throwing a panic. So for those who know in Rust, a panic is not something which you should be thrown lightly. I found this a bit of strange behavior, so I'd opened an issue on their GitHub repository. So this was on August the 21st last year. By August the 22nd, the next day, I had the founder who'd responded to me saying, hey, you found some functionality that we'd kind of that was intended, but now that you've mentioned it, it's a bit weird that it does this. It was only within a couple of days when they'd actually released a patch for this to fix this. So it was honestly, it was kind of mind blowing that I was able to just raise issues and have the founder of this particular software to say, hey, this is something, this is really valid what you're kind of raising, and we want to fix that. So really kind of positive experience in both cases. Now the reason that I was looking into using NexoSim here was because I'd seen a bit of a gap in the landscape in terms of this kind of software that I've been interacting with. So as I said in the introduction a little bit, a lot of what I do is advanced analytics and simulation work and stuff like that. And so the landscape of software in this looks a little bit like this, where you've got your big proprietary license players like AnyLogic, Simulate, Arena. So these are your big proprietary software where you need to be able to afford licenses to be able to use. But there are also free and open source alternatives as well, which is like NexoSim and SymPy. So these are available for anyone to use. The downside of them is that they might not have the same kind of utilities that your proprietary versions might have instead. And so I wanted to see if it was possible to have something which is free and open source, but then also had some of those nice utilities that you get from the commercial options as well. So this is where the idea for QuokkaSim started. So QuokkaSim is my own free and open source library for building simulation models licensed under the MIT license. So it's built in Rust on top of the NexoSim package. So it acts as a bit of a more user-friendly wrapper around NexoSim. And when I talk about QuokkaSim, I talk about being efficient, accessible, and sustainable. efficient being in terms of performance, it's built in Rust, so it better be performant. But no, it is actually. This graph doesn't show it, but this is a logarithmic graph. By the time you get to like running your simulation for 100 seconds, it's like 100 times faster than SymPy. But another thing I'm trying to do with QuokkaSim as well is make it accessible, right? What I mean by accessible is that I want it to be something which doesn't take a lot of time for you to learn. If you're someone who's wanting to get into the simulation modeling space and you haven't played around with simulations a lot, I want it to be something which is easy for you to learn and easy for you to build useful simulation models with. And the way that I do that is by hopefully having good practices and abstractions built in, or at least what I think are good practices and abstractions. You're free to tell me otherwise. And so, like, part of the reason, for building QuokkaSim was, for my own use, to kind of like scratch my own itch and, try to fix a problem that I was seeing. But another part of this was also trying to give back, right? So I'd mentioned about all of these open source libraries that I've been using before, and that helped me to get to where I am at the moment. So, like, can I actually use something like QuokkaSim to, give back to the community? So I'm going to talk a little bit about the impact of free and open source software. So when we talk about impact, so impact can be in all sorts of different terms. We could be talking social impact, environmental impact, economic, educational, cultural impact. Ultimately, impact is the change in some sort of outcome, and the outcome is the thing that we are interested in changing, right? So in the context of philanthropy or in social impact, we might say that the outcome is the level of well-being experienced by people or the condition of the natural environment. In more commercial settings, when, for example, in an economic context, we might say, okay, there are kind of key KPIs that we can look at. There are key numbers that we can have a look at. In those cases, it's a lot easier to measure impact, right? We have the KPIs there. But when we don't have those KPIs, when we're talking about social impact, environmental impact, often we don't have those numbers, and we need another way in order to help us to quantify what this impact is. One way to do that is through this resource called the 5 Dimensions of Impact. So we can think about, what is the outcome we're trying to impact? Who's impacted by this change of outcome? How much impact is there? What's the contribution of what we are doing to that change in outcome? And what's the risk associated with that as well? So, and when we talk about, how much impact we're having as well, we can think about the amount of impact being, what's the reach? So how many people are we, able to impact with whatever it is we're doing? What's the depth of the impact? Are we just having, are we having a small impact across a lot of people? Are we having a really profound impact on, the people that we're trying to influence? And we can also think about the duration. Are we having a short-term impact or something which is a bit more long-term? So to kind of talk a little bit about the impact of free and open source software, I think it's best to go through a few different examples. So this here is Open Data Cube. So this is an example of a package which makes it easy to manage and analyze large quantities of satellite data, right? So if we apply the 5 dimensions of impact to this, right, what is the outcome which is being affected? Well, it's the amount of time and effort it takes in order to organize this kind of satellite data and to do these analyses with the data as well. Who's affected? So researchers and professionals who might be wanting to, who might have a use case for, dealing with their raw satellite data. In terms of, how much impact it has in, overall, in terms of the contribution, in terms of the risk, those ones are a little bit harder to quantify. So I didn't notice until I was kind of doing the research for this talk, but Moodle is actually an example of open source software as well. Has anyone here heard of or used Moodle before? Yeah, okay, quite a few of us. So for those who don't know, so Moodle is an open source LMS platform or learning management system, right? So for example, I remember that my high school used it to help organize their learning resources for us. And this is an example of something which is open source as well. So there was a case where in the University of Moratuwa in Sri Lanka in 2016 where they were able to implement Moodle. And in doing so, they reduced their printed paper usage by about 6 tons. So in terms of environmental impact, right, so the outcome which is being affected here is the paper usage, right? Who's impacted? University staff, university students. And in this case, they were able to quantify the how much in terms of 6 tons just in a single year. So an example from social impact. So OpenIMIS is a software which is used to help support the administration of health financing and social protection programs as well. So what is the outcome which is affected here? It's the time and effort required to set up these operational tools and for health financing and social protection. Who's affected? So it would be the project teams who are setting up these systems in the first place, and by extension, and to an extent as well, also the downstream users of these of their services as well. And so in terms of like how much impact this has, again, like the specific amount of impact is difficult to quantify, and the same with the contribution and the risk. But those are more kind of abstract examples, but I think these hopefully should be a little bit more familiar to those in the room today. So another great example of free and open source software with impact is the GNU project, which I mentioned was started in the 1980s. So GIMP is, for example, an image editing software, which I use to remove all of the backgrounds and make all of these nice and transparent. So GNU Octave serves as a replacement for MATLAB. Linux is used basically everywhere, I'm sure as you would all know. R is also an example of a language which is licensed under the GPL as well. And if anyone's compiled anything with C using GCC, that's also a part of the GNU project and also licensed under GPL. So a lot of times it is difficult to quantify, this impact, but but there was a report done by the Harvard Business School that was looking into, okay, what is the impact of the open source software community as a whole, right? And so they estimated the supply side value of open source software, and just the widely used ones as well. This is not all of them, but they estimated that at $4.1 billion. So this is the amount of money it would take to recreate all of the open source software that we use today, which are most widely used. And that is just of recreating in the first place. The value that is achieved by all of this, so on the demand side, is closer to $8.8 trillion. So it might be hard to see, the individual impacts of, individual libraries and things like that, but we can very clearly see the impact of the open source community as a whole. So we talked about impact being the change in an outcome, right? So that impact can be easy to quantify or more difficult. In the cases where it's more difficult to quantify, we can use something like the 5 dimensions of impact, like the what, who, how much, contribution, and risk to analyze that. And we saw that FOSS impact can take a lot of different forms. It can be in forms of tools that directly aid the social or environmental causes that we care about. There might be tools that kind of make other tools more accessible, right? There might only be proprietary solutions out there so far, and a free and open source alternative is making that more accessible to people. It might be a way to reduce costs, and it might also be a way to create a platform for others to make an impact, like with the GNU project. And again, even though it's hard to quantify the individual impact of some of these software, they can have a very large aggregate effect. All right, so I mentioned that one of the reasons that I wanted to try to build QuokkaSim as well was also to try to give back and have an impact, right? So can I actually make an impact by doing something like launching QuokkaSim? So in terms of, okay, what is the outcome that I'm trying to affect by having QuokkaSim? So it's the amount of time and effort it takes to build these type of simulation models. Who is impacted? So in my mind, it's new and junior simulation modelers, people who don't necessarily have a lot of experience in simulation modeling, but who want to get into the field. Or it might also be modelers who have used proprietary software, but want to move away from that for whatever reason. In terms of how much impact it's going to have, what the contribution that QuokkaSim is going to have to this, and the amount of risk, that's all to be seen at this point. So I mentioned that one of the things I'm trying to do is make it accessible, and one of the ways in which I'm trying to make QuokkaSim accessible is not just by having a code package that kind of sits there. It's also by producing resources around it, such as the QuokkaSim book, which is a Rust book for kind of learning to use QuokkaSim. And I've attempted to record my own videos as well. I've a lot of room to improve there. I can't watch that one back. It's quite embarrassing for myself to watch back, but hopefully it's making a positive impact. And actually, so I had released those resources a few months ago, and it was only a week or so after I'd done that where I'd already kind of gotten my first response to to some of the resources I was putting out. I haven't really kind of like really publicly announced Quokkasim. I think this is the most publicly I've really spoken about it to this point, so I haven't been marketing it and such. But even at that point, I had people kind of like raising discussions on my GitHub repository. So this one person had kind of opened this and said, hey, I'm playing around with this example that you've kind of shown, and was wondering about how to extend that to his own kind of use case. So it's pretty cool, and like it's only been about like 4 years since that point where I was kind of still wasn't sure if I could really call myself a developer, right? To this point where I'm now confident in my skills as a developer, and I'm trying to launch something which is open source, and I'm the one who's kind of on the responding to those issues and discussions now. So I'm not. The point of this talk isn't to try to be a sales pitch. So I'll wrap up the Quokkasim part here now. But like, I'm currently looking for feedback from people who are kind of interested in learning simulation modeling or for more experienced simulation modelers, and also to looking into some potential use cases as well to start making an impact. So if any of that sounds interesting to you, you can find me down here at the end of the talk, or I'll be hanging around out there for a little while after the talk as well. Would love to have a chat. So one of the reasons I want to do today's talk as well was to also like give all of you a bit of an idea of how you can make an impact as well, right? So we'll have a look at some of the ways in which you can make an impact. So I've been talking a lot about contributing towards open source software, right? And actually, some resource that I'd found recently as part of the research for this was this opensource.guide link that I've got here. Again, so I've got all the links to all of the material in this as part of my GitHub later that I'll link. But they're a really great resource, and they've got loads of these articles like how to contribute towards open source, or how do you start your own open source project. I really should have read some of this before I actually got started, right? But I really highly recommend reading through that if contributing to open source via code is something that you want to do. But contributing doesn't just look like contributing via code, right? It doesn't mean you have to be like building out features. It can be, it can be submitting bug fixes for things that you've kind of seen when you've used the library yourself. Oh, I've run into this issue, and I can. This might be something I'm able to fix for everyone, not for myself, right? It might also be in the form of writing examples and documentation and tutorials and things like that as well. It might also be in the form of design. So a lot of the open source software had like nice kind of logos and stuff which I could flash on the screen. A lot of them don't as well, right? Some of them need a little bit of design help as well. And design can also be in terms of like the design of the actual repository itself, right? How do you actually design a library which is easy for people to be able to use and to maintain and to contribute towards? So a bit of the developer experience lens there. So it can look like organizing events for that particular open source software as well, like whether that be webinars or in-person meetups and things like that. It can be writing, so like I said, documentation. It can also be in form of tutorials, blogs, things like that. It can be in the form of contributing towards the community, right? So like for everyone who raises like a GitHub issue, there's someone who's hopefully responding to that as well, right? So a lot of these communities need people to also respond to these to issues and things, and to help build that sense of community. Like I think, like Kate kind of said before, right? This culture and community, this is something that needs to be actively worked on. It doesn't just kind of come out of existence from a vacuum. And finally, if you're in the position to support financially and not just in terms of your own time and resources, then that's a great way to be able to support the open source libraries that you know and love as well, to be able to sponsor them. So in terms of creating impact beyond just a specific library as well, if it's not just a specific you want to contribute towards, a lot of that is also applicable to on a wider scale in terms of like creating content, right? So I don't know how many of you here know of Fireship.io on YouTube. Yeah, I'm a big fan of his work, right? That's the only way I stay up to date with whatever's happening in terms of AI nowadays. But like. And part of it is entertainment and such, but it's also a great way for me to kind of know what's going on. So there's obviously some amount of impact that's happening there as well. If creating videos and recording yourself isn't your thing, like it is with me, then it can be writing articles and blogs and things about what are the types of learnings that you've had from the software that you've used. What's the knowledge that you can share? And also being a part of your community as well, wherever that is, wherever that's on Reddit, Discord, Stack Overflow, Another really great way that I've found to have an impact is by teaching and mentoring others. Like how I mentioned that, I've only been able to get to this point where I am today, calling myself a developer, because of specific people really helping me to get there. And that's a great way that you can give back towards your community as well. And finally, by organizing events like DDD Perf, like we're here today for. So something like DDD isn't possible without the many hands that kind of put together that are put together to make something like this possible. So I said at the start that any sufficiently advanced technology is indistinguishable from magic, but I think just the way that we have open source software as a thing which anyone across the world can access, for free as long as you've got an internet access, I think that's pretty amazing. And the community that we've built as a global open source community is pretty amazing as well. In what other kind of industries do you have this level of global openness and collaboration, really? So whether you're kind of technical or non-technical, there's ways for you to make an impact in the software space. So if you'd like to see any of this material again, if you'd like to have a bit more of a dive into the specific references and the reports I mentioned, all of that will be available on my GitHub pages here. You can follow the QR code here, or you can follow the link, or you can find me on LinkedIn and then follow the link that I'll be posting on my LinkedIn. So if you're keen to talk more about open source or about efficient simulation modeling with Cockasim, we'd love to have a chat with you after this. I'd like to once again thank all of our sponsors for making DDD Perf possible, and all the volunteers and organizers as well for making it possible. And I'd like to thank all of you for listening to my talk as well, and hopefully I've had an impact on your own developer journeys.